The modern use of communication technique requires high-speed data services with the ability to communicate between several devices on a same network and same time. As a result, a need is generated to increase the number of inputs as well as outputs through a single device. In today's lecture, we will talk about this technology in wireless communication, which is known as multiple input, multiple output, also known as MIMO. It is a very powerful technique in wireless systems. The structure consists of multiple antennas at both transmitter and receiver end to improve the communication performance. Also, it proves higher capacity, throughput with enhanced quality of service without raising the transmitted power of antennas. Propagation model of MIMO. The propagation model consists of several parts like data modulators, transmitting and receiving antennas, demodulator, and wireless channels. The data that is to be sent is divided into multiple streams and then coded on different transmit antennas. In an ideal MIMO system, the bandwidth of n kbps is allocated to the system, and thereafter it is distributed among all other users equally. Technically, each user gets 1 by n of the entire bandwidth. To recognize the independent signals that are transmitted in MIMO systems, a channel matrix H is formed. At the receiver end, the channel matrix is identified and the individual transmitted signals are isolated and estimated. When H is equal to 1, in general size of the channel matrix is equal to Tx into Rx, where Tx is equal to the number of transmitting antennas and Rx is equal to the number of receiving antenna. The MIMO system can be represented as Tx, Rx elements. Here, Aij represents the single input, single output channel between ith receive and jth transmit antenna pair. Mathematically, MIMO system can be represented as Y is equal to Hx plus n, where Y is equal to the received signal vector, H is equal to the channel matrix of size Tx into Rx, X is equal to the Rx into 1 transmit signal vector, N is equal to the Tx into 1 noise additive wide Gaussian noise vector. Generally, the rank of the Mimo channel can be determined by the algebraic order of the Tx into Rx channel matrix. The rank of the channel matrix is equal or less than the number of transmitting antenna and the number of receiving antenna. Thus, the number of independent signals that can be transmitted through a MIMO system is equal to the rank of the channel matrix. Channel capacity of MIMO. Let's take an abstract communication system to introduce the concept of capacity, where a series of bits are transmitted to the receiver. In the case of a single input, single output SISO channel encoder at the transmitter side transform the bits to be transmitted into the code word, such as B bits are mapped into the code word X1, X2 till Xn. These code words are then sent to the receiver. At the receiver side, the decoder translates the receiver code word to recover the original message. The following figure describes the input bits of the data to be transmitted. The output bits stand for the original message for the receiver, while Xn symbolizes the code word. In MIMO systems, the space dimension is added due to the use of multiple antennas at both ends of the communication system. The two-dimensional matrix represents the code word data that is produced by the encoder at the transmitter side. Here, Xmn represents the data transmitted by the mth antenna and received by the nth antenna. X1 and Xm represents the transmitted code word, where X1 is equal to X11, X12 till X1n. That is the code word transmitted by first antenna. So we can say Xm is equal to X1m, X2m till Xmn. That is the code word transmitted by the mth antenna. Mimo system capacity when channel is constant. The capacity of the Mimo system when transmitter and receiver are aware of the channel matrix is denoted as, where H is equal to the channel matrix, H to the power rho is equal to the transpose of the channel matrix, Q is equal to the covariance matrix. With this, we have come to an end of this session, and today we have learned Introduction to MIMO system, propagation model and structure of MIMO systems, channel capacity of MIMO, MIMO system capacity when channel is constant. We'll meet again with another interesting topic of wireless communication. Bye.